So we're now going to talk about key factory method operators that are defined by the observable class. And we'll cover other factory method operators later. I'm really going to just focus on the ones that are most important to understand for the programming assignment, but be aware that there's a whole slew of these things. As you might expect, factory methods are used to create various types of streams, in this case, streams of observables, taking input sources that are non-reactive and adapting them to work with the reactive paradigm and the reactive streams framework and implementation that's provided by the RxJava environment. So let's start by taking a look at the first and simplest of these factory methods. It's called just, and it creates an observable that will emit the given element or elements, and then it will complete, which means that the next operator in the stream, in the chain or pipeline of operators will be called. As you can see, just is a method that takes a var_args parameter, which basically means it's an arbitrary sized array, and it'll return a new observable that will be so-called captured at assembly time. In other words, it's eager. And what that means is it'll generate the data sources to emit in the thread of the caller. Very important to remember. Also important to remember is because this is an observable and we can have a bunch of data to emit, then this observable can emit multiple elements, whereas the just operator from single, which we didn't really talk about, but you should be aware of, only can emit one element because singles can only have one element, as you might expect. This factor method is commonly used to take non-reactive input sources and adapt them to work in the reactive model. So here's a very simple example, which we'll take a look at when we look at the case study later, that makes an observable stream out of 4 big fraction objects. So it's going to make a stream, and then we'll chain other operators on this later to do other things like map it and do other ways to terminate the stream and so on and so forth. Remember, just is evaluated eagerly at assembly time. And what that means is that the just method always runs in the context of the thread where the observable is instantiated. Other operators, other factor methods we're about to talk about, fromIterable, fromArray, also work this way by doing eager evaluation. We will talk later about other types of operators that run in a lazy way, and that matters because they'll end up running in the context of the thread where the rest of the stream is running. If that doesn't make any sense right now, don't worry about it. As you can see here, we have a marble diagram that shows that just will basically emit a bunch of values, the marbles, and you can see that each of the marbles is emitted as part of a stream, and if all goes well, you'll have the little vertical bar at the end indicating successful completion. Project Reactor has a just method in its flux class that works exactly the same way the just method on the observable does. Don't worry too much about this. We won't talk about it much more, but just be aware that these are very similar. Also, if you recall Java streams, they had an of factor method that could make a stream of objects, in this case, big fraction objects, using of. So once again, same idea. You can have a factor method that makes a stream of things. There's also a couple of other factor methods. I will go through them quickly because they're very similar to other stuff. They're also eager. This is the fromArray operator that turns an array into an observable. Nothing too surprising there. Once again, you can use this to adapt non-reactive input into reactive streams, programs. Here's where we're going to take an array of integers and turn it into an observable. Project Reactor has a fromArray method that works exactly the same. And surprise, surprise, the of method on Java streams also works the same way. So you can see there's a lot of congruence or parallel structure, if you will. Not parallel in the concurrent sense, but just parallel in the sense of being able to behave the same way in all these different programming models. The next method we're going to take a quick look at is called fromIterable, and it takes a Java iterable, like a list, for example, or a set, and it'll create an observable from that. So you take some kind of iterable, which again, if you take a look here, you can see you would have something like one of the various sets or lists or collections or whatnot, and that's a way to take Java collections and turn them into observables. So here's a simple example. We've got a list of integers. We can convert that into a observable stream of integers from the Java list collection. No surprise here, Project Reactor Flux has a fromIterable method that works exactly the same. And you've already seen how this stuff works with Java, where if you have a Java collection, you can turn it into a stream by just saying list.stream. Notice the difference. This is baked into the Java class library at its very fundamental level with Java collections and Java iterables and so on. Whereas with RxJava and Project Reactor, we have to have a method that takes one of these things. It's not built in. You can't take any collection and automatically turn it into an observable or a flux. The next method is a little different. It's called fromCallable. It reserves an observable that when the observer subscribes to it will do certain things. And what it does is it invokes a callable parameter. As you can see here, it's callable. You've seen callables before. Callables are essentially functional interfaces that will return a single value. And the observable that's returned from fromCallable will emit the value that's returned from the callable parameter. And this, once again, can be used to adapt non-reactive input sources into the reactive model. So, for example, here, we're making an observable that will emit a random big fraction. However, there's something very important that makes fromCallable different from fromArray, fromIterable, and just. And that is that it's lazy. And what that means is that this parameter here, this callable, in this case, callable lambda expression, isn't called until the observable is subscribed to. And that means that this call can be done dynamically. So you may get different values back and it may run in a different thread, whereas with things like just or fromIterable or fromArray will run in the thread of at the assembly time. So it'll run in the thread of the creator, not the thread where the actual operation is being subscribed to. And that's a very important distinction. We'll talk about that later. Project Reactor has a mono fromCallable that's similar to observable. However, there is no fromCallable operator in the flux, which is rather kind of perplexing. So that's the end of the key factory method operators in the observable class. For your purposes in assignment 5, you'll be using fromCallable or some variant of that quite a bit. And when we get into the concurrency models a little bit later, you'll see how and why we use fromCallable. And that's the one that you'll be focusing on for the most part.